Alright, in this video, in this lesson, we're going to be talking about the Pythagorean Theorem. So what is the Pythagorean Theorem? Pythagorean Theorem is a theorem that states on a right triangle, now this works not for any triangle, it must be a right triangle. If I find A, the length of A, and I square it, which would ultimately give me the area of this, and I find B, and I square it, and B squared would give me the area of this. If I add the two areas of those, it will equal the area of C squared. So again, A squared, so I find this length right here on a right triangle, A squared plus B squared will equal C squared. So again, only on right triangles. So what are the parts of the formula? So again, you set A squared plus B squared equals C squared. Again, it's only for right triangles. On this, this is your A, this is your B. It's also kind of like finding the length or the area of a rectangle. It doesn't necessarily matter which one I call my base and my height, just as long as they're attached to the right angle. By that I mean, I could actually label this B and this A. What matters is that your hypotenuse, or your C, is always the leg of the triangle that does not touch the right angle. So again, our parts of the right triangle are, we have our A, we have our B, and we have our C. Again, the A and the B are interchangeable. All that matters is that your C, the leg of the triangle, is the leg that does not touch the right angle. So, in the example we have here, we have A squared plus B squared equals C squared. On this, the A is 3 units long, the B is 4 units long. So 3 squared, exponent, is 9, 4 squared is 16. If I add those together, I get 25. So on our C, it's 5 units long, 5 squared is 25. 25 does equal 25, so we know we did it correctly, we know it's a right triangle. Okay, so the first part of Pythagorean Theorem, besides the formula and the components of the theorem, so we're going to talk about Pythagorean Theorem triplets, as they're sometimes called. So what this means, you could see a problem where it asks, are the three numbers, if I plug them into the Pythagorean Theorem, would it actually equal give you a right triangle? Which means if I square the two smaller ones and add them up together, the two smaller numbers, and square the larger number, would they actually be equal to one another like they were on this one where 25 did equal 25? So our first example is 5, 12, and 13. So what I'm going to do is write down the formula, A squared plus B squared equals C squared. Then I'm going to plug in what I do know to solve for what I don't know. My two smaller ones are 5 squared plus, I did a 5 squared plus 12 squared. Does it actually equal 13 squared? 5 squared, as we know, is 25. 12 squared is 144. And 13 squared is 169. Does 25 plus 144 equal 169? Yes. So it is a right triangle. Again, the two smaller ones, 5 and 12, square them, add them up together. Does it equal the larger number when you square it? If it does, it is a right triangle. Let's do the next one. So A squared plus B squared equals C squared. So we're going to do 6 squared plus 8 squared. Does it equal 10 squared? So let's see. 6 squared is 36. 8 squared is 64. 10 squared is 100. Does 36 plus 64 equal 100? Yes, it does. So it is, in fact, a right triangle. Last one. 7, 9, and 12. So we have green on this one. 7. Oh, I can't see that very well. Stick with red. 7 squared plus 9 squared, does it equal 12 squared? Let's see. 7 squared is 49 plus 9 squared, which is 81. Does it equal 144? So 49 plus 81 is 130. And 130 does not equal 144. So it would be a triangle, but it wouldn't be a right triangle. So this one is not a right triangle. The other two are. Okay, so again, two smaller ones, square them, add them up together. We got 130. Our large one, 12 squared is 144, and 130 does not equal 144. So in this example, they're asking us to find x. How are we going to find that missing length? Well, thankfully, we have a right triangle, so we can use the Pythagorean Theorem. So what we're going to do is write down the formula, a squared plus b squared equals c squared. I'm going to plug in what I do know to solve for what I don't know. And now my c, we stated earlier, is always the leg of the triangle that it's not touching the right angle. So this is my a, this is my b, or vice versa, it doesn't matter, but I'm going to stick with 6 as my a squared, 6 squared, plus 10 squared equals c squared. Okay, and let's set this up and solve it algebraically. So 6 squared is 36, 10 squared is 100, equals c squared. So then I'm going to add them together. Now the problem with this is I don't care what c squared equals. I need to find out what c equals. So to do that algebraically, I have to find we'll do this in a different color, we'll do it in black. I have to find the square root of c squared. So the square root of c squared is c. Of course, we have to keep our equation balanced, and whatever we do to the right side, we do to the left side. And the square root of 136. Now, this is an irrational number. If it's not a perfect square, such as 144, square root of 144 is 12, square root of 100 is 10. If it's not a perfect square, it's going to be an irrational number, which means it can't be written in the form of a or b, means it's a decimal that goes on forever with no pattern. So it's approximately, two squiggly lines means about approximately 11.66. Okay. Again, that's not the exact number, but that's pretty darn close. So if I wanted to know how long x was, it is approximately 11.66 unit, 11 and 66 hundredths units long. I didn't give you feet or miles or inches, so it's 11.66 units. All right, that's how you find it. Again, we did our a squared plus b squared equals c squared, and again the c is the leg of the triangle that's not touching the right angle. Plug it in, solve it algebraically. Once we get to the point right here where we are at c squared, I need to go from c squared to c. To do that, I find the square root, and again, whatever you do to the right side, you do it to the left side. That's how we got it. All right, on this problem, and I didn't draw it in here, but let me draw this now. It is a right triangle. So what if I was given the dimensions below? 7, 15, and x. Now I can use okay, where was I? Okay, so we have 7, 15, and x. It's a right triangle, so I can use the Pythagorean Theorem to find, I'm going to go with red, find my missing length. So I'm going to write down the formula. A squared plus b squared equals c squared. So I'm going to plug in what I do know to solve for what I don't know. I know my 7 is my a. Again, it could be my b, but who cares? I'm going to say it's my a squared. Now, here, I'm missing my b. I know my 15 is my c because it's not touching the right angle. So b squared equals 15 squared. So I know 7 squared is 49 plus b squared equals 225. Now, like solving an equation, this is an equation. I need to isolate the variable. I need to get the b alone. To do that, I need to get rid of the 49. So currently 49 is positive. So the inverse of that, of adding 49, would be to subtract 49. And whatever I do to the This zeroes it out. Whatever I do to the left side, I do to the right side. And this leaves me with b squared equals 176. Now, again, I don't care what, I care, but I don't care what b squared equals. I need to find out what b equals. And to go from b squared to b, I find the square root. Because the square root of b squared is b. In all equations, whatever we do to one side, we do to the other. And again, this is not a perfect square, so it's going to give me an irrational number, but this is going to be around 13.27. 13 and 27 hundredths. Now, on the Pythagorean theorem, your C must always be the longest leg of the triangle. Let me say that again. Your C, if I go back to our original example, notice this was the largest square. So the C is always, and it's going to be the longest leg, it's always going to be the longest leg because it has the largest area. Okay? So going back to this, why am I bringing that up? Because my X or my B must be smaller than 15, which it is, so we know we did it correctly. So my X, or I put B, either way, is approximately 13.27, 13 and 27 hundredths. So again, on this one, 15 was my C, 7 is my A or B. On this one, I plugged it in as my A. I'm looking for my X, my B squared. Okay, solve it. Plug in what you do know to solve for what you don't know. Set it up. Work it out algebraically. Once I get to the B squared equals 176, I find the square root. The square root of B squared is B. Whatever you do to the left side, you do to the right side. And the square root of 176 is approximately 13.27. All right, so on this example, on this right triangle, we have 10, 20, and x. Again, my 20 is my C because it's not touching the right angle. So since it is a right triangle, okay, so I'm going to write down the formula. A squared plus B squared equals C squared. I'm going to plug in what I do know. I know my A is 10 squared. I don't know my B. And again, we could make this here B and this here A, but again, I made X my B squared equals 20 squared, because it's my hypotenuse, the leg that does not touch the right angle. So I'm going to square each of these, so it's 100 plus B squared, and leave it like that because I don't know what B is, and 20 squared is 400. I'm going to solve that algebraically, isolating B squared. Okay, so when I'm isolating B squared, I'm going to get rid of the 100. The inverse of 100 is subtracting 100. Those zero out. And then whatever I do to the left side, I'm going to do to the right side. So 400 minus 100 is 300. And bring down the B squared. All right, so I got B squared equals 300. Now, I don't care what B squared is. And now you need to find what B is. So how to do that? You find the square root of B squared, because the square root of B squared is B. Whatever you do to the left side, you do to the right side. And the square root of 300, again, it's not a perfect square, so this is approximately 17.31. Or no, sorry, 32. 17 and 32 hundredths. So again, this makes sense because, again, our A and our B must be less than our C, and 17 and 32 hundredths is definitely less than 20. So we know we did this correctly. So my X was 17 and 32 hundredths. Let me write this. It's a little, the whiteboard, 32 hundredths. All right. So again, let's go back one page. Pythagorean theorem. We got our A, our B, and our C. Our C is always, and this involves in right triangles, our C is always a leg that doesn't touch the right angle. And again, it's A squared plus B squared equals c squared. If they equal one another, like on this one, 25 does equal 25, we know it's a right triangle. And again, what is it saying? That I can find the missing length in any right triangle using this theorem. So I hope this has helped understanding and how to solve Pythagorean theorem problems. If you have any questions or need additional help, you can email me at jhewlett@leisd.ws. Thanks.